The second half of Chapter 4 is all about solving. Part of what's required for solving is the ability to convert from one form to another. Now, in the first half of Chapter 4, we converted from intercept and vertex form back to standard form just by using order of operations. However, when we start with standard form and want to convert to intercept form or vertex form, we have different methods. 4.3 is called factoring quadratics. So factors are just numbers that go into other numbers. And factoring is what will help us convert from standard form to intercept form. And if you recall, intercept form is the 2 parenthesis rule. Down below, before we actually get into the quadratic part of it, it says what are the factors of each term? And one thing to note with this is we're going to want to include positive and negative options. So here's what I mean about positive and negative options. It says what are the factors of each term? And our first option is 12. Now there's lots of numbers that go into 12. And if I just start with the lowest factor first, I know that 1 times 12 would equal 12. But so would negative 1 times negative 12. That is a pair of factors. 2 and 6 would go into 12, and negative 2 times negative 6 would go into 12. There's another pair of factors, 3 and 4. They are factors of 12, and negative 3 and negative 4. It's important to note the positive and negative options when we get into the factoring conversion for quadratics. Let's try the next one, 19. 19 I know is a prime number, so only 1 and 19 technically go into 19. However, they can both be negative. Both of those pairs would multiply to get positive 19. Now, I'd like you to try 24. See if you can come up with all the positive and negative factors of 24. Pause the video, write them out, and then press play, and we'll see how many we have together. Were you able to come up with 8 different pairs of factors of positive 24? I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. They all multiply to get positive 24. And when they're all negative, same thing happens. We would have 8 choices to pick from in our factoring process. What happens if we try to find factors of a negative number? So now instead of saying 1 times 72, we would have to pick one of those values to be negative. For example, we could do negative 1 and 72. They would have a product of negative 72. Or we could flip-flop that. So a little bit different than the ones prior. We could do 2 and 36, make the 2 negative, or we can do 2 and 36 and make the 36 negative. Maybe. There we go. How many others could we come up with? I know 3 times 24 equals 72, so I'm going to make one of them negative. And then I'll make the other one negative. 4 goes into 72 18 times. There are lots of factors of 72. As we utilize this in our processes for quadratics, these are the kinds of things we have to work through. 5 doesn't go into 72, but 6 does. 6 times 12. Either the 6 could be negative or the 12 could be negative. 7 doesn't go into 72, but yep, 8 does. 8 times 9. If one's negative once, then the other one would be negative. There are that many choices to come up with factors for negative 72. And it's important to know all of your choices for what we do down below. As we start to factor quadratics, one thing that we look at is called a common factor. And a common factor is a number or variable that all terms have in common. And when we look at a quadratic or just any expression really, it ends up kind of looking like the distributive property when we're done. So taking a common factor out of terms is kind of the opposite of the distributive property. Let's take a look at some examples on the right. It says find the common factor. As we look at the first expression, it's not even quadratic. This one is technically linear. 4x plus 12. Each term in this expression, we have a 4x and then we have a 12. A common factor is something that we could take out of both of them through division. Well, I know that the numbers 4 and 12, the biggest common factor is 4. So if I take 4 out of both of them, it's like we're dividing. But I'm not going to have 4 go away. I'm going to place it out in front of the expression and then use this kind of division rule to see what would be left over from that original expression. 4x divided by 4 means we'd have just an x left over. And then the constant 12, if we factor out a 4, technically we're dividing. 12 divided by 4 is 3. This expression is equivalent to the original term, or the original expression, sorry, not term. It's just written in what's called factored form. This means 4 is the common factor. As we convert from linear to quadratic, let's see what we could find for a common factor here. X squared plus 6x. Notice the first term, the x squared term, doesn't have a coefficient out in front. Technically, that would be 1. But we wouldn't use 1 as a common factor. If we look at both of our terms, we have x squared and 6x. It's pretty easy to see that they both have an x variable. So if we think about dividing that out of both terms, again, it doesn't go away. We're just putting it out in front of our parenthesis. So we're kind of just factoring it out of each term through division. And then to see what's left over, if we take that quadratic term x squared, but divide an x out, there would be an x left over. And then plus for the sign in between. We had 6x for our second term, but if we factor the x out, we would just have 6 left over. The equivalent expression to x squared plus 6x in factored form would be x times x plus 6. And the x is the common factor. The last one is a transformation of a quadratic function in standard form. We have 6x squared plus 12x plus 4. Now a common factor has to be something that we can take out of all 3 terms. To be a common factor, it has to be able to come out of everything that's originally there. I see a 6, I see a 12, and I see a 4. The biggest common factor that comes out of all 3 of those numbers at the same time is 2. So I'm going to divide each of them by 2. And even though the first 2 terms have x's in them, because the 4 doesn't, we can't include x as our common factor. If we put our 2 out in front, we're going to use that division to see what would be left over on the inside of our parenthesis. 6x squared divided by 2, 6 divided by 2 is 3, and nothing comes out of that x squared. And then we have plus 12x over 2 would become 6x, and then 4 over 2, we'd have a 2 left over. This is the equivalent expression, and 2, I don't know, I underlined all of that. 2 is our common factor. When we look at factoring quadratics that maybe don't have a common factor, we have a different approach. And we're going to start first when our a value is 1 for a quadratic function in standard form. It's going to be important to know what a equals, what b equals, and specifically what c equals. When we have a quadratic function, we're going to convert it from factored form to intercept form. So if you look back up above, we ultimately need 2 parentheses when we're done. To get those 2 parentheses, what we're going to do is find factors of c. Oops, I needed an s in there. Factors plural. Factors of c that combine to get b. So they would either add or subtract. And that's why we had to recognize that we can have positive and negative factors, because sometimes that b term could be positive or negative, and same with c. Once we figure out a pair that multiply to get the c value, those factors, but also combine to get the b coefficient in the middle, then our 2 parentheses will always have an x, and then we have to figure out what goes in the blank, and that converts it to intercept form. One other thing to note, there may or may not be a number out in front when we're done. We'll just kind of see what happens with that. So there could be an a there, but there might not be. All right, let's give a few a try over here on the right. Factor each expression if possible. Not every quadratic is factorable, But if it's factorable, we know the steps over on the left-hand side to know what to do to solve, or to know what to do to factor. Always check for a common factor first. Let's practice a few of these questions down below. Starting with factoring x squared plus 7x plus 12. Now remember the rule is find factors of c, that constant, that would combine to get the b value in the middle. C is 12. So numbers that go into 12, we could do 1 times 12 or -1 times -12. We could do 2 times 6 or -2 times -6. We could do, I don't know, I put a comma there. Hang on. Sorry about that. All right, so -2 times -6. We could do +3 times +4 or -3 times -4. Now, those are the only factors of 12. Hopefully, one of those pairs would combine to get that +7 for the b value. Well, 1 and 12 aren't going to work, so neither will -1 or -12. 2 and 6 are close. They would give us 8, but that's not what we want. +3 and +4 would add to get us +7. So that's step 1, just kind of finding that pair that multiplies to get C and adds to get B. So then step 2, we're going to write our 2 parentheses. Notice the A value out in front is 1, so it's just going to stay 1 in our factored form. Also notice, everybody, this is an expression, not an equation. So we don't have it equaling y or f of x. The first thing we do in our template is we're just going to split apart our x squared into x and x. Now the 3 and the 4 are both positive here. We're literally just going to write +3 and +4. And that's the intercept form for our quadratic function that was originally written in standard form. And one way to check it, if we multiplied everything together, we could do x times x and get x squared. We could do x times 4, and that would be 4x. We could do 3 times x, and then 3 times 4. Combining those two terms in the middle, we would get x squared plus 7x plus 12. And again, we're just converting from standard form to intercept form. Let's try the next one. What makes the next one different from the one we just did is now look at what b equals. In the middle, b is -7 instead of +7. So we already have that list for 12 over on the left-hand side. We talked about 1 and 12, -1 and -12. I don't know what I'm doing. Sorry. I said 12, but I wrote -12. So over here on the left, we already talked about 1 and 12, -1 and -12, 2 and 6, -2, -6. Now 3 and 4 worked for +7x, but I think we need -3 and -4 to get our -7x in the middle. And once you find that pair, and hopefully with practice that comes to you, you don't have to list everything out every time. Once you know the pair that would multiply to get the C and add to get that B value in the middle, you can go right to intercept form. Your x squared will break apart into x times x, but now this time we have -3 and -4, and that's the factored form. Our final example in this top row is specific because we have 2x squared minus 10x minus 72. I notice right away that there's a number out in front that's different than 1. We have -10 and -72. In this expression, we have a common factor. That's going to mean a couple of different things for us. We start the factor process by taking out that common factor. So let's take out the 2. Again, it's technically dividing, so if you want to write the divide 2 on the top, that's fine, but really make sure that you still include it on the outside. Now, 2x squared divided by 2 would leave us with just x squared. -10x divided by 2 would give us -5x. And then -72, but if we divide by 2, gives us -36. And now instead of working with the 2, the 10, and the 72, we're really going to focus on x squared minus 5x minus 36. 36 is negative, so that's going to kind of change up how we determine what our factors look like. I know 1 times 36 is 36, but I need one of those numbers to be negative in order for us to get -36 as a product, like so. I know 2 goes into 36 18 times, so either the 2 could be negative or the 18 could be. 3 goes into 36 12 times. One of them has to be negative. 4 goes into 36 9 times. So one of them has to be positive, or the other one. 5 doesn't go into 36, but 6 does. So either it could be one positive or one negative. That wouldn't matter which one you put first or second. Can you see which pair would also add to get that -5 in the middle that we want for B? If you thought +4 and -9, that's correct. Very good. We know that 4 times -9 would give us -36, but 4 plus -9 would give us -5 for that B value in the middle. To write our final answer then, we have our common factor out in front, and then we do our 2 parentheses. The x squared should separate into x times x. The 4, notice, is positive, so that's going to be +4. The 9 was negative, that's going to stay -9. This is our factored form, or our factored version of the quadratic, which would put it in intercept form. And that's a good stopping point for our lesson. I would like you as homework to try D, E, and F. See if you can factor them to look like the intercept form answers we have up above.